Differences between OOP, object-oriented programming, and procedural programming. Object-oriented programming, OOP, and procedural programming are two paradigms for writing computer programs, each with its own approach to structuring code and solving problems. Here are the key differences between OOP and procedural programming. 1. Basic concept. Procedural programming. Procedural programming is based on the concept of procedures or routines, which are sequences of instructions that perform specific tasks. Programs in procedural programming are structured around procedures, which can manipulate data stored in variables. Object-oriented programming, OOP. OOP is based on the concept of objects, which are instances of classes that encapsulate data, attributes, and behavior, methods or functions. Programs in OOP are structured around objects, which interact with each other through defined interfaces and inheritance relationships. 2. Data handling. Procedural programming. Data and procedures are separate entities, with data typically stored in variables that can be accessed and manipulated by procedures. Procedures can modify global or local variables directly, leading to potential issues with data integrity and code maintenance. Object-oriented programming, OOP. Data and procedures, methods, are encapsulated within objects, promoting data abstraction and encapsulation. Objects interact through methods, which can manipulate internal data, attributes, while hiding implementation details from external code. 3. Code reusability. Procedural programming. Code reuse is achieved through functions or procedures, which can be called multiple times from different parts of the program. Functions in procedural programming are typically organized hierarchically, with subroutines calling other subroutines to perform tasks. Object-oriented programming, OOP. Code reuse is facilitated through inheritance and polymorphism, where classes can inherit attributes and behaviors from other classes. Objects can be reused and extended through inheritance, allowing for modular and flexible code design. 4. Modularity. Procedural programming. Programs are typically organized into functions or procedures that perform specific tasks in a sequential manner. Modularity is achieved through breaking down tasks into smaller subroutines, enhancing code readability and maintainability. Object-oriented programming, OOP. Programs are organized around objects, which encapsulate data and behavior into reusable components. Modularity in OOP is achieved through class definitions, where each class represents a distinct entity with its own attributes and methods. 5. Focus on data and behavior. Procedural programming emphasizes procedures or routines that manipulate data stored in variables. Control flow is managed through procedural constructs like loops, conditionals, and function calls. Object-oriented programming, OOP, emphasizes objects that combine data, attributes, and behavior, methods or functions, into cohesive units. Control flow is managed through method invocations on objects, promoting a more intuitive and modular approach to programming. 6. Examples. Procedural programming. Examples include languages like C, Pascal, and BASIC, where programs are structured around procedures and functions. Object-oriented programming, OOP. Examples include languages like Java, Python, and C++, where programs are structured around classes and objects that interact through methods and inheritance. In summary, while both OOP and procedural programming are programming paradigms used to write software, they differ significantly in their approach to structuring code, handling data, promoting code reuse, and organizing program logic. The choice between OOP and procedural programming depends on factors such as project requirements, code complexity, team preferences, and scalability needs.